All right. So my name is Tovio Roberts, and this is another episode of Latent Topics in Data Science. Apologies, I'm using my headphone mic today. I'm in the process of switching up my sound, and so the sound quality probably won't be as good as it usually is, but we'll get through it, and I'll stream on this topic again if the sound isn't sufficient. Also, usually I use this green screen in the background. I'm not doing that today because I'm not, because of some slight technical issues that I'm still working out. Okay, so today's going to be a little bit different. I'm not going to be live coding today. What I'm going to be doing is talking about what to do between passing your technical interview and your start date for the DSI. And I've been getting a lot of questions recently from students who have passed their technical interview, thus being accepted into the Galvanize Data Science Immersive, about what do I do between now and then. The answer to this question depends on a few things. To start, how much time do you have between now and the start date? What skills, aside from the requisite Python and stat skills, are you bringing with you into the program? What is your subdomain of interest in data science, if you have one at this point? And you don't have to have a domain of interest, by the way, currently. You're going to explore subdomains in data science and machine learning while you're in the DSI. So don't worry about that. But if you have a field of interest, the sooner you start working in that, exploring it, digging into things, the more that you're going to get out of the DSI, because the tools you learn in the DSI you'll be able to directly apply to things that you're primarily interested in. Another important question is, well, probably the most important question, is where are your weaknesses? So before we get into most of those questions, I'm going to point out that we have a pre-course, and where you focus your studies, really depends on how much time you have between now and your start date. We have this pre-course that will be released to you soon, and that can take anywhere from 15 hours of work to over 40 hours, depending on your quantitative background and your prior skills. So let me just pull that up really quick. This is sort of a peek into our pre-course that is not released yet, or this is our prior pre-course. I'm not going to, dig into it too far. I'm just going to show you what kind of topics we're currently covering. So keep in mind that this is as of July 2020, and we're likely going to update and add materials to this. So don't consider this to be exhaustive at this point. The short story about pre-course is that it covers the basics that you'll need to be successful in the DSI. If you've been accepted into the program, we assume you have the capacity to be successful and have a good outcome from the DSI, and this pre-course is more to establish your general foundation than it is to sort of introduce new concepts. So yeah, let's just scan through the topics here. Let me resize this so it's easier to see. Just pull it away like this. And yeah, so notice we cover in-terminal text editors a little bit. This gets a bit into the terminal in general, and it's a good idea to become familiar with your terminal. That's something that you'll be using a lot. We cover object-oriented programming, pandas, some calculus, some linear algebra, some more probability statistics with calculus, and SQL. So for many of you, pandas, linear algebra, and SQL are going to be new. Some of you will have had prior experience in these topics, and thus the pre-course will be less time-consuming for you. But for a lot of you, these topics in particular, SQL, linear algebra, and pandas, are going to be fairly new. So let's say you have a couple months before your start date, and you want to build up more knowledge, which is highly recommended. The more you know prior to the DSI, the more you can learn while you're in the DSI. Let's say you have that kind of time. I think given that, the most important question to ask is, where are your weaknesses? So where are your weaknesses? It shouldn't be news to you that data science is a quantitative field. That said, you'll want to be fluent in mathematical concepts in algebra, calculus, statistics, linear algebra. And getting your feet wet in differential equations isn't going to hurt anything either. If you pass the technical interview, then you likely have a decent foundation in probability and statistics. However, if you want to dig more into those basics, we generally recommend this site called JB Statistics. And so I'm going to just pull this up. And this is kind of the format of today. I'm going to just bring up some things and tour you lightly through them. Maybe I'll zoom in on this a little bit. And I'll also put these in the description. So JB Statistics. And I'll kind of refactor the description in a little bit. So now to be sure, we cover a lot of what you see on JB Statistics within our basic prep, as well as within the pre-course for the DSI. There are things that we don't cover, such as, if I scroll down here, we don't cover ANOVA. I think we only lightly touch on regression. What else in here? We don't touch on chi-square tests or t-tests. And there are a number of distributions that we don't actually cover in our materials currently, such as, what am I seeing here? Multinomial, hypergeometric. We don't cover those. Now, that's not because they're not important or that they're not interesting or something like that. It's just we don't cover them. We cover a set of basics in the basic prep and the pre-course on which you can build other concepts. And going through this, the lessons on here are methodical, they're interesting, they're very well presented. Jeremy Balka, who runs the site, does a great job of simplifying and making these materials really accessible. We're really big fans, and we point people at these when they ask for supplemental things. There's a lot of walkthroughs of worked problems. There's some light derivations. It's really good. So that's the place where we generally send people first if they want more statistics foundations. Now, if you're new to calculus or you need a refresher in calculus, we generally recommend Khan Academy. You'll want to work through differential calculus and integral calculus. Those are the topics that will aid you the most in understanding the machine learning algorithms that are covered in the DSI. You can even take it further. So this is differential calculus that I'm pulling up. This format, you could go end-to-end on this course and also end-to-end on the integral calculus course. And they're gonna make a big difference. If your calculus is weak at this point, if you need a refresher, if you're fairly new to calculus, in any of those cases, you're gonna find this to be very helpful. And the format of these courses is great. If you have oodles of time, you could even go further than integral calculus, and I wouldn't discourage you from doing that. So integrals are key in understanding area under the curve, and you're going to see with forward and back propagation that these Calc 2 concepts they're really prerequisite, and we do cover these somewhat in our pre-course, but we cover them as if you already have a foundation. So, that you just need a refresher. Now, if you really need to build a foundation, I would say go through the Khan Academy materials here. So if you're new to linear algebra, you might also consider doing the linear algebra course on Khan Academy. However, this won't necessarily help you in applying Python or Numpy, which is a Python library, to linear algebra. So, you could kind of figure it out. You could use Python as you're studying Khan Academy's linear algebra materials. But that's not what I would recommend offhand. We're currently working on a supplemental course in linear algebra using Numpy. However, that's a few months out from release at this point. So for now, my recommendation is an excellent book by Jason Brownlee called Basics of Linear Algebra for Machine Learning. And this is part of a series called Machine Learning Mastery. I believe that's what it's called. This book in particular, I just like it. I think it's really well written, and it takes a sort of step-by-step approach. Oh, yes, step-by-step tutorials. It's all tutorial based, and if you go through this, you're going to have a pretty solid foundation. And I'm just a fan. Jason Brownlee is a pretty well-known data scientist. You can read up on him. An important point that Jason Brownlee makes in this book is that you don't need to learn everything there is to know. And maybe that goes without saying, but I think many of us who are attracted to data science are sort of completionists in our mindsets. We want to know everything. We want to know how everything works. We want to get under the hood. We want to tear it down and build it back up. And the reality is we don't really have time for that. And there's, when it comes down to it, you need to learn how to apply everything that is currently applicable, right? And it's kind of this thing where, if you need to repair your car, you don't need to know how the brakes work in order to repair the engine. So this is kind of a great lesson in the study of data science in general. You will never know everything. And in most cases, you're barely going to know enough. And this is as you're learning new domains, learning new mathematical concepts, reading articles. Often you'll be getting by the skin of your teeth, and that's really okay. It's important to find a way for that to be okay. To trust yourself to be able to learn enough. Now, if you have the time, if you have the space, if you have a job that encourages you to expand this foundational knowledge to such a degree that you're allocating time that isn't in applying your data science, that's great. Most of us are not in those kinds of jobs. Most of us are working in some kind of business intelligence, and we're trying to make an actionable model, right, and put something into production. When you're doing that, it's important to not get in the weeds. And as far as linear algebra goes, this book definitely gives you a solid survey of what you need to know, plus quite a bit. But it doesn't give you anything extraneous, and and it is very applied tutorial based. So I'm a fan. I think that if you need to build up foundational knowledge in linear algebra, this is a great book. When we get our linear algebra materials in place, I'll note that in the description. But for now, I think this book is an excellent way forward. Oh, I think I stated that I would be pasting in links as I put them up. So let me just do that so that they get updated in the description as we're going. You might need to refresh the page to grab those links, but you know what? I'm going to also put them in the chat just in case. And then I'll go back through and annotate these, refactor them, and hopefully get you on the paths that you're most interested in following. All right. Okay. So I mentioned differential equations, and really for that, there's a lot of resources you could explore with that, but I would just point you back to Khan Academy. I think they do a pretty good job, and it's sort of like having a single place to go is sometimes nice, right? And Khan Academy, I think they do a great job. I think the lectures are intended for a younger audience, and are put into some simpler terms than are a lot of textbooks, right? I think for some of these kinds of materials, when you get into textbooks, you're really hitting a wall. It's like, if you don't know, I'm not going to tell you kind of design, you know, where you have to reference a key in the front of the book really regularly. You know, if you've studied formal logic, or if you studied logic in general, this is a frustration maybe you encountered for the first few chapters in a book, where you're constantly referencing the key in the front, instead of getting an explanation, which would obviously take more paper to give you an explanation of the symbols you're using, you know, throughout the chapters you're reading. But it's almost like you have to learn all the syntax and semantics prior to learning the concept. And Khan Academy does a great job of kind of weaving that into the lessons. So, you know, I definitely recommend Khan Academy's DiffEQs. It's also short and will give you kind of a primer, as opposed to something deeper and maybe not as necessary. You know, that said, I would not spend a lot of time focusing on DiffEQs, just getting a sense of DiffEQs for optimization and transforms. Like here we're seeing Laplace transforms. It's good to have some exposure to that, especially if you're getting into digital image processing. Another thing you might look into is the Fourier transform. And that's something that I'm likely going to do a video on later, especially for let's say waveforms and for images. You know, sort of walking through the discrete Fourier transform and committing it in code in a way, you know, and then using Syfy or you know, OpenCV or something else as well to commit these things and kind of like dig into the utility of them. But yeah, that's another thing you could look into beyond differential equations. And there's all kinds of resources on that. Maybe just going to Wikipedia to start would probably help. So in your studies leading into day one of the DSI, you're going to want to write a lot of Python. And some of you are intrinsically motivated. Some of you will do what I do and write an alarm clock in Python, or you know, cut up a series of television shows that you've scraped from somewhere, right? And use some sort of procedural editing to do that. And you find yourself writing Python at multiple points in the day, just because it seems like a good way to solve a problem. You know, some of you will do that. I think the minority of you will do that. The vast majority of you will be coding Python when you're prompted to do so, or when you're working through a book or something like that, and you won't just apply it in your everyday life. Now, I will encourage you to apply it in your everyday life. Try to solve any problem you can think of with Python as best you can. But if you're building your way toward that intrinsic motivation, I would just recommend, in the meantime, using Code Wars. And I know we plug Code Wars quite a bit. We did a stream on it earlier, where we just, you know, introduced you to it and said, hey, do this, use this. We plug Code Wars for a reason, and that's that you need to be a good coder. Being a good coder isn't just writing nice code. It's being able to take a problem, break it down, and solve it in whatever way that you can, and then go back and refactor your code. You need to always be coding. And unless you are constantly coding your own projects, like I said, or coding out all your studies as you learn new materials, then you'll need to be doing upkeep and advancing your coding abilities. So yeah, Code Wars. I'm sure at this point, if you've passed your technical interview, you've seen Code Wars. You have some familiarity with it. I'm just going to view my profile really quick here. if you want, if you feel so inclined, I get some extra points if you sign up using my referral URL. So I'm just going to paste that in here just for fun. You know, it's a thing if you want to do it. But you know, otherwise, just go to the front of Code Wars, solve the simple challenge they give you, and go ahead and use that as your practice. You know, use that as your dojo, as it were. Okay. We generally suggest you do 3 or 4 Code Wars problems a day, every day. There are a variety of problems, and some of them are really interesting, but all of them are practice, and you'll need to stay in coding shape heading toward the DSI, and that's why we talk it out. Yeah, so let's talk about the basic skill set and knowledge base that will best aid you in the data science immersive. Early in the DSI, you'll become proficient in Pandas, Matplotlib, Numpy, and Syfy. These are primary tools. You'll use them every day. And although our pre-course covers these to the depth that you'll initially need them, it is going to help you a lot if you become an expert in them as build as much expertise as you can before the start date of the DSI. I recommend starting with Pandas and using Pandas to explore some data. That's really, really going to help you a lot. Again, we're working on a standalone Pandas course, but for now, I'm going to point you at Kaggle. And if you're not familiar with Kaggle, it's sort of a data science competition site. You may have heard of Kaggle competitions, and they're pretty cool. They're places to get your feet wet in the manipulation of real data. You can look at other people's works and kind of emulate what they do on a new data set or try to recreate what they've done. But this tutorial here, this Pandas tutorial, it will take you through the basics. And after completing it, you should be able to find a data set and do some things with that data set. So I'm just going to put in a link here to that. And let's say you want to find new data sets. Well, it turns out that Google has a pretty good search engine for that. And it's just datasetsearch.research.google.com. So if you want to find some actual data, it says, okay, try coronavirus COVID-19 or global temperatures. I'll click on global temperatures, and there are a ton of locations of data sets here. You can click out to them and find them. There will usually be keys for the data as well. So this is just one resource. Another resource I'm pretty into is NREL. So NREL datasets, you can go to search NREL data catalog, and this is a lot of things for renewable energy, urban planning, things like that. So, there is no shortage of places where data lives on the internet. So I'm just throwing a couple things out there. The dataset search for Google or NREL as a location, but you can find so much data. There are a lot of exposed data sets, and definitely get your feet wet once you start getting a feel for Pandas. So as you're getting into data sets, you'll realize pretty quickly that you'll also want to be able to visualize your data. And you'll generally use matplotlib.pyplot to do that. And this is one of those instances where I recommend just going to their tutorials. And starting to work through these tutorials. They've got a few levels of them: introductory, intermediate, and advanced. And then they've got some subsections that you can go through. And nice thing about this, you can download all of these as a zip file, all these tutorials, and in either as scripts or as Jupyter notebooks. So that's just, Matplotlib is your primary visualization library for Python. It's not the only one, but it's definitely where you want to start. And it's easy enough. Unfortunately, there's a lot of different ways to do things in Matplotlib or in PyPlot, but you'll get a hang for it, and you'll start realizing that you can find working plots that you can adapt to your specific use case, and that is an absolutely legitimate way to go forward. Okay, so NumPy, I mentioned NumPy. Again, I would just recommend the Jason Brownlee linear algebra book that I mentioned earlier. I think it does a great job, and it makes NumPy immediately accessible. And I think if you're learning NumPy, learning it in the context of linear algebra is going to be helpful. The other area where you're going to learn NumPy is in manipulation of digital images. So if you go into digital image processing, you're definitely going to interact with NumPy there. Also, sparse matrices for natural language processing. If you're getting into natural language processing, you're going to learn NumPy there. So I'm not going to point you at any specific NumPy tutorial. I think it's nice to pick it up in the context of something else. And that Jason Brownlee linear algebra book that I mentioned before is really good. So this brings us to Syfy. And what can I say about Syfy? I don't want Syfy to be the bane of your existence, okay? Unfortunately, their documentation is fairly terse, and though you can Google some decent tutorials on it, I would just point you to a really effective online book called Learning Scientific Programming with Python. And I referenced this book before in my tutorial, my code through of an SIR model. This book, I think, is really good. Let me see if I can. Let me see. Yeah. Long story short, it's a really good book. And oh, here we go. The interface here is a little weird. I was like, oh no, did they take down the digital, the online version of it? They didn't. It's all here. So if you go to book, mouse over here, notice they've got a Python, core Python language section. You can probably skip that. And you can probably get out into Syfy. Although, chapters 8 and 9, those might be the most relevant. You could start at chapter 6, and what you'll find is that you're using Syfy throughout these last 4 chapters. And then there's a number of projects in the errata, and yeah, I think this book is really well done. I'm a big fan, and I think this book has rigor, and it gives you immediately interesting and applicable uses of Syfy. So that would be my recommendation for Syfy. So those are kind of core libraries. Those are your core tools. And you might consider that core as being the place to put the most focus, or at least to build out your fundamentals. It's kind of like, well, you're learning how to use a hammer, and you're learning how to use a screwdriver, and you're learning how to use a shovel, and you're learning how to use, a table saw, right? I mean, these are all different things that do different things, but are all part of, building a structure. And you want to at least have passing knowledge of all of them. And so often I think it's best to build up some applied knowledge of each of those earlier than later. So once you have a decent, foundation in those, you might consider some more general works on data science and machine learning. So, first off, machine learning. I'm saying machine learning. And this phrase, you might have a sense of what this is, but let's, for the sake of this conversation, consider it to be essentially an abstraction and higher level view of your statistical skills, okay? You could consider machine learning as some sort of predictive analytic set of tools, right? Or some set of tools that you can use to cluster data into various categories, right? To kind of build out your semantics in this, there's an excellent primer in machine learning. And you'll want to start going through this when you have the bandwidth. It's called Introduction to Statistical Learning. It's free. Let me just put it in here. There's a PDF available, and I really think that if more of our students read through, the first number of chapters in this, they would enter the program with a level of confidence in what they were learning that would negate some of their stuckness, or some of the stuckness that we see people hit. As I said, the book is free online. I just pasted in the link to it. If you can get through Chapter 6 prior to the DSI start date, while paying special attention to cross-validation, that's really something that would be good to know by day 1 of the DSI, you'll have a good leg up in some of the concepts you may not have been exposed to yet. Though this book is in consideration of the R programming language, R is a statistical programming language, you can definitely do everything in this using Python. And that'll be Python using Numpy, Syfy, Scikit-Learn, Matplotlib. I would say don't do it in R unless you feel very comfortable with these other things in Python and you just want to learn R. There's nothing wrong with R. I think it's a great language. But you can definitely do everything in this in Python. There are also a number of GitHub repos people have put together for solutions to the problems in this book. And so, if you are stuck on the problem and maybe you feel like you're starting from scratch in this, you can go find other people's solutions. And I think I casually did a Google search of this the other day, and there were, there were hundreds of repositories that came up that had significant portions of the book completed. So, just keep that in mind. I think you could just read through it, but one recommendation I always make is if you're studying something, code it as well. It can be almost anything. If you're studying it, code it as well. So I also put together a YouTube playlist of lectures from the authors of this book. And if you like dad jokes, these lectures are definitely for you. I think they're really entertaining. And, the people who put this together, who put this book together, are so likable that, they're kind of the definitely the right kind of nerd for my taste. And there's, I believe, lectures through for all the materials in the book. And so if you're a visual learner, if you like having some kind of lecture format that you can reference against the text, or if you just want the lectures, they're good. I think that for a foundation in machine learning, this is a great way to go. Now, if you have a stronger quantitative background, you might want to take a look at the graduate level of this text, which is called Elements of Statistical Learning. And I'll paste that in here, and I'll put it in the chat. I'm not as big a fan of this book, to be honest, though it does have a deeper dive than the Introduction to Statistical Learning, which you'll hear people refer to as the ISLR. This is the ESL, right, or the ESLR. You'll hear people refer to it usually as ESLR. This book, it sort of requires a linear reading, I think, in the sense that you have to reference back to earlier chapters. And it's hard to just jump into the middle of the book. You know, you might look at some algorithm somewhere in the middle, and it'll reference back to, it'll say, reference back to something in chapter 1, and it won't tell you the page. And I don't know. I find that frustrating. I think that's kind of not a great pedagogical approach, but it does save them, I guess it saves them a little bit of writing here and there. It's a good book, don't get me wrong, but you know, you might want to wait. If you finish the ISLR, you might want to wait to finish that before reading the ESL. So one of my favorite intro books is called Python Machine Learning by Sebastian Raska. And not only is this book good, but the blog, you know, his blog is really good. And you know, this book's reasonably priced. I'm not recommending you buy it or anything. I'm just saying I think it's really good, and it would probably benefit you to have this as a reference and learning book, right? So the reason I really love this book is that it takes you through derivations of perceptrons, multi-layer perceptrons, and other neural net concepts and other machine learning algorithms. And not just kind of the naive or toy, I don't want to say toy, but the more simple algorithms, you know, like you know, k-nearest neighbors and least squares regression and things like that. It takes you through, it derives a convolutional neural net and takes you through coding that from scratch. So it walks you through all the mathematical formulations. It has you coding these algorithms from base Python, and it also applies them using Scikit-Learn or TensorFlow or PyTorch, and you know, other machine learning libraries as well. It's a great book for both theoretical and applied neural net concepts, and I use it all the time. I look at it all the time. You know, I have it sitting on my shelf over here, and I open it up every couple of days when I want to quickly peek at something. So in your studies of basic machine learning, you'll pretty quickly encounter supervised versus unsupervised learning. And if you want to get a footing in these ideas, I recommend honestly reading the Wikipedia articles on these topics and then looking through the sklearn, the Scikit-Learn listings for algorithms that fall under each. So I'm just going to pull up the supervised learning page here. And you know, it says here, you know, this first sentence, you know, you might want to just commit this to your understanding. Supervised learning is the machine learning task of learning a function that maps an input to an output based on example input-output pairs. So what does that mean? It means you have a data set that has a target variable, and you are using an algorithm to build a function that given new data will effectively predict an outcome. And that's a very simplistic way of saying this, but that is kind of the deal with supervised learning. You have data, and you know, you have some phenomenon you've observed for a decent period of time, or enough times, let's say, that you're able to build a function using a given algorithm that will effectively predict outcomes of new observations. Now, that's wildly helpful, and for many of you, you'll find yourself doing a lot of supervised learning, right? You can think of this as, well, let's say you have a data set of you know, images, medical images, where you are looking at you know, slices of tissue, and you're trying to discern if there's cancerous tissue in there. And you have 10,000 images, and you have all these bounding boxes. Now, what you're likely going to do is train a convolutional neural net to be able to take in a new image ultimately, once it's trained, take in a new image and present a bounding box around tissue that looks cancerous, right? Wildly helpful. If you have this ability, then you're offloading the diagnostic work of a technician or a doctor, or you're amplifying their work. You're giving them a red flag potential, by just through just simple imaging, right? So that's a brief moment of supervised learning. And I mentioned Scikit-Learn. So I'm just going to bring up the landing page for Scikit-Learn's supervised learning. And what this has is all of the supervised learning models that are in, or algorithms that are in Scikit-Learn. And you could, if you felt so inclined, and I am definitely not discouraging you from doing this, you could go through these one by one, right? Read about them, perform, the example code that's here, and there's a lot of example code here, and build out a fairly decent understanding of these algorithms. So, I'm not going to discourage you from doing that. I think it's an approach that I took when I was learning these materials, and it gave me a very clear idea of what's out there, right? There's a lot out there, and this isn't exhaustive by any means, but there is a lot here. Now, let's say you want to know how these algorithms are written. Well, that's a really nice thing about this this library. So I'm going to go GitHub, linear. Well, let's do just Scikit-Learn, and let's look at the GitHub for Scikit-Learn, and let's look at the code for a linear model. So I'm clicking on this Scikit-Learn directory, and if I go down here to, I think it's under generalized linear models. Where is it? I can probably just reference back to here. Ordinary least squares. Why don't we find ordinary least squares? So from Scikit-Learn, import linear model. Great. So it is just linear model. It's right here. So linear model, and in base.py, we're going to be able to find essentially our ordinary least squares. So let's see how it's applied here. We've got linear regression right here, and if I look for, I think I can just look for linear regression. Oh, it might not be there actually. It might be, I think it probably is in here actually. That's what it is. It's, there we go. So here's our class for linear regression, and these comments are great. They give you a very clear sense of things, and as you'll notice, there's good examples in here. There's solid annotations for each of these functions, and let's say you want to code linear regression from scratch and adapt it to something. Well, here's your base code right here. You can take this, copy it out. You would need to build out the dependencies, right? Because this is going to be dependent on some other things. But essentially, you can walk through this code and see, because of the nature of Python, you have your linear regression algorithm built right here. So that is a way to approach learning these materials, and I think it's a great way to do it if you have the Python chops and you are willing to put in the time. So that's supervised learning. Oh, you know what? I was going to just copy Scikit-Learn's GitHub and paste that in as well, just to be complete in this. And so that, that's kind of a quick look at supervised learning. And then, we can look at Scikit-Learn's unsupervised learning as well. Here's our Wikipedia page. Unsupervised learning is a type of machine learning that looks for previously undetected patterns in a data set with no pre-existing labels and with a minimum of human supervision. Okay, what's an example of this? Let's say you have a collection of purchased items with some kind of customer information attached. Now, you don't necessarily have a target variable here, right? You just have a big collection of data. Now, what if you want to segment people into different groups that buy similar items in order to better advertise for them? You might do that through an unsupervised approach, an unsupervised algorithm. And what you might decide is, well, I think there's 10 different types of people here. And you make these 10 different groups and sort of parse your customers into them. And then you deliver 10 separate advertisements across them. That might be a business application for unsupervised learning. So that's the Wikipedia page. And the Scikit-Learn page, what you'll see here is that this is not unlike what we've already seen, right? What we've already seen for supervised learning. These models tend to be pretty different, right? Supervised and unsupervised models tend to be different. Again, there's examples of these. You can run those examples locally. You can run all the code locally if you have a full Python environment installed with Anaconda. So I'll just paste those in as well. All right. I think getting a baseline understanding of these concepts and the related algorithm descriptions will give you a nice high-level view of the kinds of problems that you will engage with ultimately as a data scientist. This does it with toy data set examples, but you can play around with those examples. You can run them locally, and you can generally go find data and plug it in and out. Use different data sets. Try to make predictions and try to find something that has utility. Make that project, put it in a gist on GitHub, or make a GitHub repo for exploring some kind of data. And that ultimately becomes a portfolio piece, or at least becomes a reference point if you're trying to do something similar in the future. So I mentioned earlier something to the effect of, what subdomain are you interested in data science? And as I said, you don't need to have one. You can go into the DSI as a generalist, and you can start digging into a subdomain while you're there. It's likely that you are bringing in some type of domain knowledge, though, right? Like, if you're going into the DSI, what we see primarily is people with strong professional backgrounds going into the DSI. They're coming in having done a lot of work in some field, either as scientists, as financial experts, as doing business analytics. Maybe they've been programming, maybe they've been software developers for a number of years. Primarily we see people with strong professional backgrounds. And some people don't necessarily have strong professional backgrounds. We do get, people who are just out of college. We get people who have, only a couple years of work experience behind them. There's this great diversity of people who come into the space. But if you're bringing in a strong set of domain knowledge, then it's probably going to be helpful to let that domain influence where you put your focus in in terms of a subdomain of data science. So, for example, if you're, let's say you're a graphic designer, we don't get too many graphic designers from what I've seen, but we do get some, artists, professional artists, digital artists. We get people who have done, digital image processing prior to joining the DSI. But let's say, you have some kind of visual design, architecture, whatever it might be, background, and you have some interest in image processing. If that's the case, I recommend, getting your feet wet, maybe digging into digital image processing in general. There's a great classic work on this topic, and it's just called Digital Image Processing, and it's by Gonzalez and Woods. So I'm just going to open that up. This is a book that I went through when I was in school, and I think so. There's a couple editions of this. You could honestly use the 2nd edition or 3rd edition or the 4th edition. I've never looked at the 4th edition, but notice that this book is focused on MATLAB, and I definitely do not recommend that you get into MATLAB. I do recommend utilizing Python and some specific image library to accomplish the same tasks that you see in this book. Now, a cool thing about this book is that about these books is that they present you with the algorithms, and MATLAB is pretty readable. And so, if you're given MATLAB code and you really, you spend some time with this, you'll be able to adapt that MATLAB code to Python. And so the book being in MATLAB isn't really a deterrent. In fact, I think there's something pedagogically interesting about translating algorithms, right? So translating an algorithm that's written in one language that, honestly, Python and MATLAB don't look that different from each other. It's sort of like Python and R don't look that different from each other. But I think there is a pedagogical boon to translating MATLAB into Python, which is a lot of what I did when I was in school, where the class was actually taught in MATLAB, and I decided I would just do everything in Python because I didn't want to use proprietary software, or not that there are open source programs that use MATLAB, but I just wanted to use Python, and I wanted to make something more portable. But you can perform all the tasks that you see in this book, and a lot of the filters that you see designed in these books, or that you see utilized in these books, are built into other image processing libraries. So where I would recommend you start in terms of image processing libraries is skimage, and it's a nice little library. It's very accessible. And it's got good tutorials, good example code, the kind of thing where, if you look at their general examples, you look at their gallery, there's a lot that you can do here. And you can take the images that they use, right, and you can swap in your own images. And what you'll find pretty quickly is that you've got a lot of material here that you can apply, especially in the pre-processing of images for your capstones in the DSI, if you choose something, some kind of data, some kind of image data. So I'll just go ahead and paste that in. And let's see. You can also take a look into OpenCV, which is an industry standard library or set of tools. It's a little more language agnostic, so you'd have to use, I think it's either CV2 or CV3 at this point for Python. It's a bigger install, and the learning curve on OpenCV is a little bit steeper than skimage. So, if you're just getting into it, my recommendation would be to start with skimage and move on to OpenCV for anything, as you become more comfortable with image processing in general. Okay. So let's imagine a different scenario, right? You're not coming from a digital artist background. Let's imagine that you are coming from a writing or language studies, English background, maybe a literature background. In these cases, you might consider starting out by digging into natural language processing. Your starting point for this is likely going to be the Natural Language Toolkit, which, sort of like Scikit-Learn, is an academic library, and I think it's great. There are other libraries though. There's Syfy, there's GenSim, but NLTK is a great place to start, and they also have an exposed code base, so you can look through how they do things. Now, what I'm going to say about this is, this is pretty excellent. They've got this wiki, API. It's very education-based, right? This is educational material, and it also can be applied, right? So the thing is, though, you are probably best served by going through their book, which is this kind of amazing 90s themed thing. Just takes us back to the dawn of the internet. Don't let it fool you. It's really good, and it'll take you through much of the fundamentals of natural language processing, and we'll do it in an applied way. It won't take you much further than the fundamentals, honestly, but those fundamentals will aid you quite a bit in the DSI. So, if you have an interest in natural language processing, I'd recommend you definitely go through this book and start playing around with projects like go to, there's a big, Project Gutenberg, and go download a bunch of books and do some sort of analysis across different books. I mean, that kind of project will give you a lot of insight into natural language processing, and will, at the very least, teach you, give you some knowledge of what you don't know, but will also give you, it'll pull down the intimidating aspects of natural language processing. One thing we see is that, the reason why I bring up image processing and natural language processing is that in the DSI, we see a lot of people who are intimidated by these concepts or by these subdomains. And, part of that is the DSI moves very fast. And if you don't already have some foundations in these, they're going to be hard to attach to, right? Even though, two of the largest kind of fields of expertise within data science, or two of the most important fields of expertise, are digital image processing, computer vision, and natural language processing. And so, if you're trying to attach to something immediately, but you're not sure which direction to go, I would say choose one of those, unless there's a very clear path in your prior domain knowledge. So there are so many different potential subdomains in data science that I could get into, that I could talk about. If you have specific questions on resources for things like quantitative finance, signal processing, pedestrian detection, data science for the social sciences, give a comment here, and I'll come back and respond to you directly in the comments. Or if you're in our Galvanize org, our DSI prep org, reach out to me on Slack, and we can meet up and talk about appropriate resources to dig into. I have, I read a lot, and I study a lot, and there are a couple places where I have more specialization, namely in natural language processing and digital image processing. But I read works outside of my domain quite a bit, and I can definitely point you at resources. I just don't want to get into all of them here because we could be here for a while, right? So kind of along those lines, if you want to get into the world, like the diverse world of materials, of topics, I'm going to recommend that you take a look at archive.org. And archive, it says here, is a free distribution service and open access archive for nearly 2 million scholarly articles in physics, math, computer science, all of these things, quantitative finance, statistics, etc. Now, the quote-unquote data science in this is spread through a lot of different topics. And so what I'll usually do is I'll just go to Google and I'll say cite archive.org, and then I'll search for something. And let's say I'm going to search for thermal pedestrian detection. I'm searching for this because it was a field of research I was in, and here we go. We start off right away: pedestrian detection in thermal images using saliency maps. All of these are pedestrian detection using thermal images. And as you can see, there is an entire paper here. You can just grab the PDF here. It's going to load, well, it'll just load in here. I'm not actually downloading it. I'm just loading it in the browser. But this is, if you're researching a topic, using the Google site search for this will bring up more papers than you have time to read. And, not only is this paper going to give you a lot, you can just go down to the references here, and this will take you out to a whole lot of other papers, most of which are published on archive. So, basically you can find a massive amount of scientific papers on archive. And if you Google machine learning cite archive.org, you'll get a massive list of papers. It's a great tool for exploring subdomains or just learning what's on the cutting edge of machine learning. I spend a lot of time here researching projects and generally getting humbled by how much is out there. There is so much out there. And that harkens back to, you're not going to have time to learn everything. And so learn what you can use. That's really, really important. So at this point, you might be feeling a bit overwhelmed, which is very understandable. Just keep in mind that you could simply complete the pre-course for the Galvanize DSI and be in a decent position for success in the program. I do recommend pushing yourself further, though, and anything extra you learn will help you profoundly during and after the DSI. So if you have the time and motivation, and if you've interviewed early, then consider this moment to be the calm before the storm. The DSI is difficult, and anything you can do now to make it easier, you'll appreciate while you're in it. And this list of resources is just a starting point. If there's further questions, feel free to reach out to me, either in the comments here or over Slack if you're in the DSI org, DSI prep org. So, all that said, let's consider your priorities. If you want a more concretized list of priorities, this is what I would say. 1, pre-course. 2, Python practice. Practice. Be good at Python. 3, get good with pandas. Pandas is going to be vital. The better you are with it, the faster you're going to burn through datasets. You're going to be able to explore them quickly, you're going to be able to understand what's going on quickly. 4, get good with Matplotlib, for visualization. You're going to use pyplot all the time, and you're going to find that the explainability of your data has everything to do, well, often has everything to do with how well you can visualize it for people who don't understand what's there, right? That's how you help them understand. And 5, choose your own adventure, really. If you're good with those first 4 things, pre-course, Python, Pandas, and Matplotlib, you can kind of take a few different directions, and that can look like digging into the basics of machine learning, exploring datasets with Pandas, applying simple Scikit-Learn models to those datasets, exploring a specific domain or a subdomain like natural language processing or digital image processing. You could get into Amazon Web Services or Google Cloud, provisioning machines up there and doing some machine learning in those spaces. You could also work more on differential equations or Fourier transforms or kind of the more esoteric filters in image processing or signal processing. There's a lot of different directions to go, but I would say handle your prerequisites, right? Make sure you do the pre-course for DSI. Make sure you understand everything in there. Be good at Python. Get good with Pandas. Get good with Matplotlib. Everything after that is kind of gravy, So I'm going to stay on for a bit, and I'll answer any questions that come up. Feel free to post in the Slack channel, underneath my post in there, or you can post questions in the YouTube chat. If I don't see any questions in the next couple minutes, I'll sign off, and feel free to reach out to me anytime. I pretty much live on Slack, so I'm happy to address anything in there. Yeah, in the meantime, how cool is this, right? This is these saliency maps for thermal imaging. I think above it said that these are using some kind of recurrent neural net, and we get these really nice segmentations out of this. This is part of the joy of of data science is looking at all the cool stuff other people are doing. I mean, look at these these are really tight thresholds on. This looks like a data set that I used before. I wonder if it is. Yep, it totally is. It's the cased multispectral pedestrian data set. I actually presented something on this on a different day, but yeah, I think what I did with this is I made predator vision, which kind of acts like a saliency tool, although in these cases they're looking for a tight threshold, I believe, and although it's saliency, it's not necessarily developing a bounding box, or at least I didn't see them developing bounding boxes. Although, oh no, there they did. Yeah. Okay. Yeah. So they improved their bounding boxes through using saliency, which is pretty awesome. And that's just one of so many articles on this topic. So as I'm waiting for any potential questions, I'll just open a couple of these up because it's cool. I don't know. Yeah, I can kind of get lost in archive. Just that there's so much, and there's so much new stuff as well. So this appears to be a very different data set, and I think it's again, it's a tagged data set. I see a question here. Hi, I'm coming from a psychology, psychotherapist background. Are the domains in data science somewhat related? You know, there was a student I worked with, I believe in the fall, maybe in the early winter, who was also coming from a psychologist background, or was working as a therapist and had done a master's in psychology. And there were really interesting diagnostic models used in psychology that you know, we walked through one of those models. You know, he just wanted to show it to me because it looked a lot like a neural net model that I had been talking about. And looking at this model, I felt like if I took the time, I could code out something. You know, I could code out this diagnostic model. And I think this is sort of true in psychology. I think there are diagnostic models being worked out. Well, I know there are diagnostic models being worked out quite a bit in medicine. I have some friends who were doing postdoctoral work in super comprehensive natural language processing models for disease diagnosis. And there were, you know, we would just geek out on this. And I know that there are models that look like this in psychology, but that might not at this stage be implemented as machine learning models. Does that make sense? So, you know, why don't we just take a look at this? Let's say psychology, machine learning. I'm imagining this will bring something up towards deep learning models for psychological state prediction using smartphone data. So this might be more of a philosophical paper. I'm not entirely sure, but you know, I imagine that this paper can give you some lead-in to, you know, I would say do that Google search that I just did, but also, you know, take a quick perusal of this paper. It might give you kind of a lead-in to some other things. Something else I really got into, I think maybe a year ago, was neural nets based on common hallucination, like hypnagogic hallucination. And it's kind of wild, you know, like somebody had built this big a reference space, like of 60 or 70 hallucination patterns related to you know, what people experience, like say when they're poisoned or when they have their eyes closed prior to going to sleep, things like that. And they really built convolutional neural net, something like a convolutional neural net for object detection based on hallucination patterns. And that's wild to me, that because it seems, I don't want to say it seems like a stretch, but it was kind of a stretch, right? And they had really effective object tagging through their convolution filters being built off of human hallucination. Thought that was brilliant, and so that's kind of a maybe an extreme subfield, let's say, but it's still kind of amazing that data science, machine learning, you know, application of neural nets is in every domain. And so, you know, I'm not as familiar in the domain of psychology, but I know it's there through things that I've gotten into talking with, you know, this friend of mine, and also just Obviously on archive, there's a lot of stuff. There's another question here. Is web scraping something that we should look into before the DSI? Will we touch on it at all in the bootcamp? Short answer, yes. I would say yes. If you want to get into web scraping, there are a couple ways you could start in this. If you aren't already familiar with just accessing APIs, I would say start using let's say the Twitter API or Reddit's API, and just pull some things down, scrape some things off of those sites, and try to process them a little bit. Try to create some brief pipeline. Beyond that, if you want to build a solid foundation in web scraping, and you haven't already looked into it, look into Selenium. And there's going to be tutorials. Yeah, this might be a good place to start. Actually, this looks pretty good. I've never gone through this tutorial, but this is not official documentation, but this does actually look like a web scraping oriented tutorial. So you know what? Let me just drop that in the chat, and I'll also put a note in the description. I use Selenium quite a bit for more often for automation. Not necessarily for scraping. If I can get away with using an API, I'll use an API. Or even curl. Using curl in the terminal against an API, and I'll write a quick bash script or something like that. But when I do use Selenium, it's great. Like if you have to traverse the DOM and utilize dynamic, traversing the DOM in situations where there's dynamic page loading or some sort of kind of JavaScript boundary, and maybe you need to work in some mouse automation in there too to get like a quick copy paste of something. Selenium's the jam. They do an amazing job. Also, if you're doing other kinds of automated user interface testing, this is going to be your way forward. So, yeah, I would say you don't need to build up much knowledge of web scraping prior to the DSI, but it's like a lot of these things. If you build it up, it's going to have massive returns, right? Suddenly, the data sets that are available to you are not limited to curated data sets, right? You can go out and really custom scrape. Like you could build a crawler of, let's say, YouTube videos that scrapes low performant comments according to a YouTube user profile that has displayed a certain set of interests, right? You can't do that with an API. It's something that you can do if you have the vision and you have a good working knowledge of Selenium. All right, I think I'm going to wrap up here. Yeah, thanks so much for watching. I'm going to leave this video up, and if you have any other questions, feel free to reach out to me on our Slack org. If you aren't part of our, our Galvanize basic prep, let me just pull that up really quick. If you sign up for our basic prep course, we'll send you a link to, we'll invite you to our Slack org, and there are people working in there on these materials, on our Python materials. It's all self-paced study. We check in with you. You can access us. You can reach out to us on Slack and ask questions. So if you're not already part of the Data Science Basic Prep, doesn't hurt anything to join it and become part of our Slack org. And if you have any other questions, you can reach out to me there. You can also reach out to me via my Galvanize email address, which is just tovio.roberts@galvanize.com. Thanks so much for watching, and hope this is helpful. If if you see this and something comes to mind that you would like, that you'd like me to address in terms of preparing for the DSI, or if there's a specific topic you'd like me to cover that fits into our sort of, let's say, mid-elementary level Python programming for data science, the kinds of tutorials I've already been giving, feel free to make a suggestion, whatever that might be. Like, I was actually considering doing a walkthrough of some of the concepts in the Natural Language Toolkit book, because, well, it's just, requisite knowledge for natural language processing. So it's one of those things that we could really effectively cover here if you're interested. So if you can think of anything like that, feel free to put in a suggestion, and I'll add it to my queue, and we'll do our best to deliver it. So yeah, thanks everybody, and enjoy your afternoon or evening.